We will solve this today's LeetCode problem. The question is filling bookcase shelves. So we have given an array books where book size is equals to thickness and height. Right, indicates the thickness and the height of the ith book. So you are also given an integer self width. We want to place these books in order onto bookcase shelves that have a total width self width. We choose some of the books to place on this shelf such that some of their thickness is less or equal to self width. Then build another level of shelf of the bookcase so that the total height of the bookcase has increased by the maximum height of the bookcase. We just put down. We repeat this process until there are no more books to place. Okay, okay. Note that each step of the waiver process, the order of the books we place is the same order as the given sequence of the books. For example, if we have ordered list of 5 books, then we might place the first and the second book onto the first shelf and the third book on the second. Okay, and if we return the find minimum possible height so that the book shelf can be after placing the shelves in this manner. So the question is just like we have given thickness and height of each book, right? Of each book, which is representing in book size, right? So we have given a thickness and height, right? And place this we need to place the books in the bookshelf, right? If you imagine a bookshelf, how the books are placed just like that. The first, second, third books in the first row, then comes down to the second row, third, fourth, fifth, then third row, six, seven, eight, like this, right? That's how the books are placed in the bookshelf, right? So but here bookshelf's height, can be adjustable, right? Bookshelf height is adjustable according to the question, right? And we need to place the books as such that the height of bookshelf will be the minimum, should be the minimum, right? The should be the minimum, right? Should be the minimum, right? That's the question is asking, right? We need to place the books as such that the height of the bookshelf should be minimum, right? And how we will put the books? So we need to put the books we need to place the books in order which is given in the question, right? In the order which is given in the question, right? Given in the question. So basically we can't put the first book, then we can't then third, then fifth. uh, that's how we can't place. We need to place in order, like first, then second, then fourth, third, then the fourth, right? This is how we can place the books on the bookshelf, right? And we need to find the height of the bookshelf. So if we see the first example here, if we see the first example here, sorry. So this books is given, right? This is height, this is thickness and the height. The first is thickness and the second is height. That's what is given here, right? Okay, and the self width is 4. So one thing is given, that we have given a self width, that only this is the width of book shelf, and the books, how much books can be placed in the in one row, which is determined by this self width, right? So how many possibilities can be there, right? So first possibility is that you place, so this is the first row, right? This is the first row of the book cell, right? So first possibility is that you place first book here with a thickness 1 and the height 1, right? You place this. So the first book takes 1 width. Now the row width is becomes 3 now, right? Right, this is representing with. Can you put 2 the second book? The thickness is 2 and we have still left self width, right? So we can place it, right? But the height is 3, right? It means the first row height, it means the first uh, uh, first row height now becomes 3, because the first book has height 1 but the second book height is 3. So which is the maximum? 3. This is 3 height, right? Can we place the third book? So 1 plus 2, which is 3, and this is given 4, right? The cell width is 4, means this is the width, right? 4 is a width. 4 is a width, right? 1 to 3, and this 3 plus 2 will be 5, which is greater than this self width, right? So we can't place 2 3 here. So what we need to do, we need to place in the second row, right? We need to place in the second row, right? Again, this for the second row, the width will be the same, right? We can place this 2 and 3. So if you place 2 3, the second row height will be also be 3, right? And also, can we place 1? Yes, we can place 1, because 2 plus 1 is 3 and total width is 4, which is still greater than. We can place it next book also. So maximum height is in the bookshelf is 3. 3 plus 1 and 3 1 1 3 is the maximum, right? So now self width height is over, right? We need to move to the third row for placing the more numbers of this. So one thing is, see that there are options, right? There are options. So if you place this again 1, 1 comma 1, and also again 1 comma 2, all the books are placed, and the height of this is the the third height, the second the third row height is 2, because the maximum maximum height of a book is 2, on both of the books in the third row, right? So that would be row height 2. So if you see, calculate the total height, this 3 plus 3 is 6, 6 plus 2 is 8. So total height, one of the possibilities height, that height is total is 8, if we place according to this. Now, but one thing's to note that instead of putting this 2 3 here, can we place it to the second row? Yes, we can have place this, right? So instead of putting this 3, if I don't push here, the height will be 1. And if I put this here and remove this all here, so this 2 3 and 2 3 is 4. The four, both the books can be placed at the second row, and the height will be 3, right? And now the remaining ones, which are the 1 1 and this 1 1 again, right? The height is maximum is 2 in these four books, and these four books can be placed in the third row, because 1 2 3 4, there are four with total width occupied by this four books is self width, right? So now you will see this 1 plus 3 is 4, 4 plus 3 is 6. So there are possibilities like 6 also, right? This is the possibility also. And what is the minimum height in both of the possibilities? 6, 6, right? So one thing you observe here, that we have possibilities, we have many possibilities, right? We have many possibilities to place the books in the in any row which satisfy the self with condition, self with condition, right? Right. And if we have possibilities, you will always think, so if there are possibilities, if you got possibilities, if you got possibilities, you can think of one thing, you can think of DP for sure. If there are possibilities and you don't know that, because there are many possibilities now, so this one can you put at first row, 2 3 can you push at second row or third row or the last row anywhere. So you have possibilities, so you need to think of DP for sure, right? You will think of DP. And if you see the constraints are very low, right? This is 1000, this is 1000, this is 1000. So I can think of DP for sure, that the constraints are also low, and I'm saying the possibilities, that there are possibilities, so I can think of DP, right? Now, one thing to note, that if I take the example, the same example, right? If I take the same example as here and try to make one thing, that what are the changes, right? The first thing to know, that this I would be changes, right? I need to iterate this in whole books to place it, right? The first thing to for sure. So if I place it, so I will be change, right? I will definitely change. Second, that this thickness, this self width 4, I need to maintain this self width 4 for each row. I need to place this. I need to place this. Check the width for each row, such that it is satisfying. That how many books can be placed in a particular row. So it means the width, the self width, the width will be also be tracked, right? Also, I need heights, right? I need height for each position. I need height. That what should be the height? So if you see in the particular row, I need the maximum of each book height, and that will be the height of the particular row, right? But when we change this, when we change the row, the height will be the summation of the upper part and the lower part. 3 plus 2 5 plus 1 6, right? So basically, if we are in the first thing to observe, that if we are in the same row, we need to take the max height. We need to take the max height among all the books, and that will be the height of that particular row. That will be the height of that particular row, right? But if we are changing the row, or you can call it as a self, right? Self, then the previous row height will be added to current, right? That's the two things, right? And now the question is over. And how the question is over? You track of I, you track of width, and you track of height, right? And this is the maximum height. This is the this is the height for the current row, and if you are changing, this height will be added to the current row if you are changing the row, right? So let's see how will this form, right? So first thing is that we will start from 0. The width will be also 0, right? Okay, the width will be not 0. Why? The self width is 4. It means I know that this 4 will be, this 4 can be occurred, right? Also, this height would be 0. The current height is 0, because uh, we haven't taken anything, right? Okay, now if we start from here, the 0th book is 1 1, right? If this 1 1 is here, it means this one thickness will be reduced. We are placing it the first row. This is 0 is books, this 4 is something, and this is the height, right? Let me write this here for you. This is ith, this is original width, and this is height, right? If you take the first width and place it at, if I take the first width and place it at the current self, right? If I place it at current self, so that would be 1, I plus 1, because we need to move to next one. So I plus 1, we have taken this 0 to the current self. So the 4 minus 1 will be 3, and this 0 height is 1. So this will be 1, right? Okay. I haven't placed it at my current self. I want to place it at the next self, right? So again, this will be 1, but this will be the current self, right? The next self. So if you put at the next self height would be 4 enough, but that would be again 3, right? Because we have placed at the next self, so height would be same, but this 0 will be 1, height is also 1, right? So this is for next self. Next, place at next row, and this will be placed at the same row, right? That's the meaning of this. There are two options we have, right? Now again, what are the options for this? Again, the same thing. We have two options, right? The first option is either you place this this 2 3 book at the same row or in the next row. So if I put this at the same row, this will become second. This is I is equals to 2. The second thickness, the first thickness is 2, so this 3 minus 2 will be 1. And the height is, so we are placing in the same row, right? So the maximum height, which is either 3 or 1, will be placed at here. So the maximum height is 3, so that will be placed here, because we are placing in the same row. Either I will place it at the next row. If you place it at the next row, this I will be changed to 2. Also now, this we are placing it in the next row, right? So this 3 will be not be the original width. This 3 will be not the original. Let's make tell you the for this, right? This is the original width, and this is the changed width, right? This is the change width, right? Let's like write like this, and you will better understand. 4 1 and 4 1, right? So if you change this, if you're not placing in the same row, if you're placing in the next row, the width will be again 4. Because the change width will be not 3, that will be 4. So we will change the width 4 minus 2, which is 2, right? This will be 2, right? And the original width will be 4, and the height would be not 1, or height will be this 3, right? Height will be this 3. Why 3? Not matching with this one, but not matching with this one, but this is the next row, so height will be 3 according to that. The same goes for this, the same goes for this. Now again, when we again move to this, and we again move to this, again we have two options. Either I place it in the same row, or place it in the next row. So now we have the width left with 1 for the same row, and the value which is 2th is 2, thickness is 2, but we have left with 1 only for the same row, right? So we can place it. No, we cannot place it, because we have left with 1 only, and we have the thickness of book is 2. It means what does it mean? I cannot place it here, right? So it means it will be ended from here, right? This is ending from here, right? Now, one thing, if I want to place it in the next row, yes, I can place it. So this will be 2. Now this will be original, because we are placing in the next row. That will be the self width 4, right? That will not be 1, that will be 4. And the 0 is 2 again. So same thing, 2 2. And also this will be 3, right? Because this 2 is placed at his, and I will be, for the next value, this will be 2, and this is 4. So this will be original value, and the height will be 3 again, right? So this is how we place it here. Same goes for this one, same goes for this one. So first let's complete it to there, right? Let's complete it here. So again, we have again two options, right? We have again two options to place this 30th value, which is 1 1. So if I place it in the same row, that would be, this will be 4, and this will be 1, and this will be 4. Now the height we are placing in the same row, the height will be the maximum between 3 and 1. So the maximum is 3. If you want to place it in the next row, so that would be 4 minus 1, which is 3, again 4, and that will be 1, because the current height is 1. Same thing goes and goes on. But when we'll return back, so the base case will be, so suppose we are placed it in the same rows. So can we place in the fourth value, this one will be in the same row? Yes, we can place it. So 0 0, this will be 4, sorry, this will be 5, and this will be the maximum value of 3 and 1, which is 3 again, right? Same goes for 6. But for 6 we can't place it in the same row. So that would be negative, but we can place it in the next row, right? So that would be 6. And if we place into next row, this 4 minus this 0 will not be, uh, this change width will become now original width. So 4 minus 1, which is 3, and this is 4, and the height will be 1, right? The height will be 1, right? And the same goes for, now this sixth value needs to be put it out. If I want to place it in the same row, I can put it. This will be 6, this will be 7, this will be 2, this will be 4, and height is still 1, right? Height is still 1. Now one thing is to note, that we are reached to 7. We have reached to 7, right? We have reached to 7, and the total number of books are 7, though 2 to 4 to 6 and 7. If we reach to 7, we need to return it from back. So what we will return? We need height, right? We need height. So height would be this one, this height would is 1. So we will return 1 from here, return 1 from here. So, and what is 1? That is the final height, that is the height which we are storing. Because height is we are storing, so we will return this one, right? We will return this one, right? And we have this next option is that we place this 6 to the different row. So this 7, this will be 4 minus 1, which is 3, this is 4, and this is 1. So we will return both from, return 1 from here, right? In this case. And if you observe one thing, that there are also many possibilities at the leaf position, right? This there can be also possibilities, right? Because we have see only the first side of it. There can be also possibilities for this here, right? There one, there again this, right? Like this, again for this and this, again for this and this, right? So there are many possibilities, but one thing's to note that at each and every book, for each and every book from 0 to 6, there can be, there will be, there can be one height as possible, right? From 0, 1, 2, 3, 4, 5, 6, right? There can be many possibilities, right? There can be many possibilities for each and every one. For each and every book there can be many possibilities for height, right? And what are the what will the minimum height among all of them? That would be the added for all of them, right? If any word would be added, that would be added, and that will be my final answer, right? So basically we need to just return, we need to just check, we need to just check, return the minimum height among all possibilities for everyone, among all possibilities for each book, for each book, right? Either it is placed at the same row or it is placed in the next row. And this is how we will solve this problem. So basically, and where the dp comes, because when you make this at any position, there must be, there must be many overlapping conditions occurs at any positions when you make this whole tree for some small number of a small number of a small example. If you make a tree, you will see that where there are many overlapping conditions, and that, and then we need to further memorize it, right? We need to further memorize it, we need to further memorize it, right? So do you see that how will I find the conditions of dp, right? How will I find the conditions? The first thing to note that this I would definitely change. The second, that this self width will be also changed, because when we put and not put, the self width change, so self width will also condition change. Height is same for the same row, but changes with the change in the row, so height will be also be changed. So one thing's to know that we need to make the further memoization on this purpose, right? So that's how the change. So mainly what are the changing? So this zero is changing at each step, this width is changing for but at each step, and height is manageable. What, why height is manageable? Because height is storing in my answers, height is the answer, right? So we don't need to store the height also at each every position, because height is the answer. And why we are storing height? To make the track, like what do we need to return, what will be stored in my dp of I, right? So that will be the memoization condition. So what are the changing? This ith, this I of book is changing, and the width is changing, right? This is the changing, right? This is the dp of I, and width is changing, right? And what is representing? It is representing the minimum height of the bookcase, which contains books from I to j, right? We contains from I to width of the remaining surface space, right? That's what is representing minimum height for the books, for the books up to ith book, right? Up to ith, for the remaining width, for the remaining width. That's what it is representing, right? And this will contain the minimum height in my answers. And this is how we make the recursion tree. If you make the recursion tree, you will better understand that how will this is working, right? How this is working. Let's take you will need to take a small example and just make a recursion tree. You will definitely know that why this is working, right? And I have shown you the example. You must have understood it, right? If you don't, take the smallest example, right? Let's try to implement this and see how we will implement this. This implementation is very simple if you understood this, that how is this working, right? So first thing is to know that what are the parameters. The first parameters would be the ith book, right? That will be start from 0. The second parameter is width, which will be change, this that will be the change width, right? The next will be the cell width, which is the original width, right? This is the original width. The last would be the books, and also we need to maintain the track the height of the book, that either it in the same row or it is changing, right? So this is the height, right? So let's just start and solve. The first thing is ith book, the next is change width. Let's just represent it as a width, right? And the next is original width, so this is take its original width. Next is height, that will be the updated height for each row. And next is books, right? This is how it represent, right? Now, what are the two conditions? Either you include the current book in the current shelf, or in the next shelf, that is next row, right? So one thing is to know that either you take it as a take so one thing is to, and when you, okay, when you place the book in the current shelf, the condition would be if the current width, right, if the current width, which is this width, is greater than the book's height, book's width, right? So let's just represent, this is the width of books, which is at 0, and the height of the book will be at 1, right? So if the current width of the book, if the current width of the book is less than the remaining width of the book, of the row, then simply we can simply place it at here. If I place it, the height would be the maximum of all the books height. So we will call for the next, also we will change this width uh, to w. We will because the book is placed, so remaining space of the row will be changed. Also original width will be the same, and the height would be, what will be the height now? The height would be the height which was before, and now the height, we are placed at the same row, so height would be updated, and that would be the max height. So we will store the max height, that would be the height, and this h, right, that was it would be. And we will just and or write like this, right? This is the max height, right? And we will just pass it, because the height would be changed if that is greater than, and we will pass the books, right? So this is the condition when we place at the same row, right? Place the book at same row, right? But when we don't want to place at the same row, in that condition what it would be? If we don't want to place at the same row, we don't need to check any condition. What we will do, we will just add this height to the next row, right? So this will be I plus 1. And now, what would be the width? So if you place it in the next row, the width will be original width, and you have placed in the next row, so the width would be changed to this original width minus w, and that was the remaining width which will be passed out. And this is the original width, and the height would be this h only, right? And the books will be this, right? So this is when you don't place the books, when you place the book in the next row, right? So this and this, but we need to know the minimum between this and this. So what we will do, we will just take the minimum between when we place at the next row and when we place in the same row. We will just take the minimum between them and return from here. Okay. Now, what will the base case? I told you the base case would be when we reach to the last book. It means when we reach to the last number of book, when we reach to the last book, means if I is greater than n, that I have, we don't have any book left, then what we will return? We will return the height, the current height, the current height we will return. That's what we will return here, right? Right. Suppose you have only one book, so the height would be 0, and this call the next function, right? And that would be the height of h. So the current book height will be returned to this answer, and that's how you can re-verify it, that if you place it only one book, if you have only one book, what we will return this answer. So that's how you can verify this the base case, right? So if you are out of the all the books, you will just return the height of which is the current height, right? Because we are storing in this height the all the heights, right? This is the base case. So this is how we solve this question, right? So this is just a recursion, we haven't memoized it, but we can run this will be worked for small cases. But when it goes to uh, just a minute, something is wrong. Okay, change with. Okay, change with in starting nothing is changed with, the change with will be the cell width in starting, right? So let's just run this. This will work for small cases, but when we you submit it, it will give TLE because it is currently 2 to the power of n. One is for here and second is here. So it will go for each and every, but there are many overlapping conditions. So we will further memoize it. So for memoization, you know what we will done. The changes parameter are two things: the ith and the self width. So we will take a DP. I is till n and the self width will be till 0 to self width. So we will take this self width as 1 plus 1, and which initializes to minus 1, which will initialize to with minus 1, and we will just pass it with this, right? This will be DP, this will be passed it by reference. Always pass it by reference. Try to pass it, don't pass it by value, because that will create another copy that will give definitely TLE. So I always pass it by reference, right? And now what we need to do, we need to just memorize it further. For the change width, this is the width and this is the DPI. So just put this as and slice to width. And before before going further, just check that whether the current ith value with this width value is already calculated or not in previous. If it is calculated, just return its value, and if it is not, we will check further. And this is how we will further memorize it. Also we need to pass the TP in solve function, right? So this is how we will solve this question. It is just like you include it or not, right? And one thing is to note that if they in the current row, we need to take the max height among all the rows, and if you don't, you need to just check this as an original width, what will the width and height. So the main problem, let's submit it and we will conclude it. Let's submit it and check whether we have corrected it or not. We have passed all the test cases, right? So the main conclusion of this solution is that you need to know that when do you change when do you change the width, and when do you change the height. Do you change the height, right? That's the main thing to observe in this solution, right? When you are changing the width and when you change the height, and how will you implement it, that's the main thing, right? If you see, this is very easy, but thinking for this takes times, right? Thinking on this takes time, right? So yeah, this is how we solve this question, and time complexity would be. So you see that the time complexity will be that this is calculating for when we want to place in the next row, and when we in the same row, this is placing, right? And this DPI with, so that would be 2 of to the power n when you use recursion. But after memoization, we have calculated for each and every one, so that would be definitely O of n into W, right? Because we are iterating for each width and each books number of books, so that would be n into W. W is what? N is the number of books given, and W is the width of uh, this bookshelf, right? Bookshelf, which is given, right? Bookshelf. And the space complexity is, so if you see, we are taking a DP array to store this n into self width, so that would be also O of n into W. This is how we solve this problem. You can do this is a top up approach. You can also do a bottom up approach where you don't need this recursion, right? So you can do this, I am sure about that. So this is how we solve this problem. Thank you so much. Hope it helps you. Bye bye.